Hello, welcome to the video. We're continuing with our work on trig graphs. So last time we looked at graphs where we have y equals a sine bx and ones where we had y equals a cos bx. And so these told us various things about the shape of the graph. So sine or cos told us to say whether the general shape was sort of like this or whether it was like this. And then the A and the B, they told us more about it. So the A, remember, the number in front, that tells us about the amplitude. That tells us how high up the graph is from the middle to the top, and then from the middle down to the bottom. And then the B, that told us about the period. So that told us how many complete cycles there were of the graph within 360 degrees. So if there was no number here, that just means it did one complete cycle in 360. If there was a 2 here, it did 2 of them. If there was a 5 there, it did 5 of them within 360. So that tells us about the shape of the graph and its height and sort of how squashed together it is. What we want to look at now is what happens if the graph itself is moved either horizontally or vertically. Now we're going to deal with vertically first. And so the term we use for this is the graph has been translated. Basically that just means it's been moved. So if the graph has been moved vertically, we just get an extra number added to our equation and it just sits there by itself. So for example, we'll have y equals a sine bx, and then we'll just have a plus 2, for example, would mean it'd move vertically by 2. Or if we had y equals 3 plus a cos bx, it would mean it had moved vertically by 3. So it doesn't matter if this number by itself is at the end or at the start. That's just how much it has moved. And so if that number is positive, it has moved up. And if that number is negative, it has moved down. So let's do that. So if it's a positive number by itself, it's moved up. And if it's a negative number, it's moved down. So let's have a look at what that actually means. And I'm just going to draw the axis here, and then we'll pop some graphs on here. So first, let's look at y equals sine x plus 2. So what this means is the whole graph has moved up 2. So instead of it starting at 0, it will start at 2. It will start here. And so then normally the graph would go up and its highest peak would be 1 because of that amplitude. So that means it's going to go up to 3 instead because it's going to go up 1 from 2. Then its lowest point would normally be minus 1. So we'll come down 1 from the 2. And its lowest point now is going to be 1. So our graph then will be a sine curve that goes up to 3 and down to 1 like that. And because there's no number here by the x, that means it's doing one cycle in 360. So this bit here must be 360, and then that bit there in the middle must be 180. And that's what y equals sine x plus 2 would look like. Every part of it has moved up 2. So the origin has moved up 2, the peak has moved up 2, and the troughs have moved up 2. Let's look at another one of these. Let's say this time we're going to look at a cosine one. Just redraw this out quickly. And now we'll have y equals 4 plus cos 2x. So this is a positive 4, so it's all moved up 4. So your peak of a cosine, where it starts, is normally at 1. So instead, it's going to start 4 up from that, so it's going to start at 5. Your lowest part of your cosine graph is normally at -1. It's going to start 4 up from -1. So 4 up from -1 would be 3. And then it's repeating itself twice in 360. So it's going to start here, and it's going to come down like that once, and it's going to go like that twice. So we've got 360 there at the end. I should point out, actually, that all of these I've been drawing as if the graph has told us to draw it between 0 and 360. And so here, the middle point of this graph, well, that is at 4. 360 halfway through, by the time it's done one complete one, that would be at 180. And there we go. So let's look at one now where we make it a little bit trickier, and we're going to include some negatives. But you're seeing the general principle here. It just moves your whole graph up or down. Again, we're going to draw this one between 0 and 360. And let's say our equation now is y equals -2 minus 2 sine 3x. So we've got a lot going on in this one. First of all, our amplitude is -2. So that immediately tells us our graph's going to be flipped, and it's going to be going that way instead of the normal way. We're going to be doing 3 of them in 360. And the whole graph has shifted down by -2. So normally your sine graph would start here, but that has come down by -2. So it's going to start here. So normally your peak, or your lowest point, sorry, on this minus graph would be at -1. But that's gone down by -2, so it's going to come down to -3. That's a lie. Normally, your peak on this graph is going to be at 2 and -2 because of the amplitude there. I forgot the amplitude already myself. So it would normally go down to -2, but that has moved down to, so it's going to go down to -4. It would normally go up to 2, but that again has moved down to, so it's instead going to go to 0. And there, that is everything we need to do. I'm just going to move this point down a little bit to try and keep it even. There we go. It's going to come down like that to -4, up to 0. That's it done once. And it's doing it 3 times in 360. So let's do another one, and then let's do another one, and by this point here we're at 360 degrees, and that means after one of them it's 120, and after 2 of them it's 240. And there we go. So it's actually not too complicated when you're moving your graph up or down. You just shift everything. Now, what people often find a little trickier is if you're moving it horizontally instead. And so, if you're moving your graph horizontally, what you get for your equation, I'm just going to use 2 blank examples. So we get y equals a sine b, and this time the x bit is going to go in brackets. And so I'm just going to pick a number. We might get 30 instead. And that's telling us that the graph has moved horizontally 30. Or we might get one where it's a cos b x minus 90. And that tells us the graph has moved 90 horizontally. So, one important bit to note though is this number here. If that number is positive, it means the graph has moved to the left. And if that number is negative, it means the graph has moved to the right. So this is like when we were looking at quadratics and things. Positive actually means it moves to the left, and negative it means it moves to the right. So let's say we've got one function, and we'll keep it simple. Y equals sine x plus 90. So this number here is positive, which means the whole thing has moved to the left. And I'm going to do things a little bit differently here. The way I actually find this easiest is to draw out your function first and then put the axes on after. I just find that easier. Make sure you get the nice smooth graph, but you can do it both ways. In fact, I will do it both ways to keep it clear for you. So your sine curve is going to look like that. And normally it would be 360 here, 0 here, and 180 here. But this has all moved to the left 90 degrees. So this has all shifted this way. So your 360 here, this point is no longer at 360. It's gone left that way, so it's done 360 minus 90. It is now at 270 degrees here. This point here, no longer at 180, it has shifted left that way, so it's now at 90. And this point here is no longer at 0. It's now shifted left that way by 90, so it's now at minus 90. So, on this graph now, where would your axis be? So you're still going to have this line going through the middle, obviously, for your x-axis. But your vertical line at 0, well, that's now here, isn't it? So that's now what your sine graph looks like. It's starting over on this side of the axis instead, because it's moved horizontally. Now, if we wanted to do this the other way and we want to draw the axis out first, that's perfectly fine to do. We'll just mark on it where all our points are going to be. So normally your starting point is going to be at 0 here. It's not anymore, it's going to be at minus 90 because it's moved left 90. Normally your end is going to be at 360, but it's moved left 90. So now it's going to finish at 270. Normally where it crosses is in the middle at 180, but that has moved left to 90. That's probably enough to start drawing it, but if you wanted to, be extra careful. Normally your first peak on a sine graph is at 90, and that's moved left, so it's actually at 0. And normally your first trough is at 270, that's moved left, so it's at 180 in here. And then we can join these up if you want. So either way of doing this is absolutely fine. Just whichever works best for you. I like drawing the graph out first because then I can immediately picture, okay, this is the end point and it's moved that way. This is the trough and it's moved that way. But either is fine. So let's look at some slightly more complicated examples then of this. Let's say we have y equals 2 cosine x minus 20. Now our cosine graph, our 2 cosine graph, is normally going to look like this. And it will have this line going through the middle. And we're going to be at -2 here and 2 here. So normally, this point here where it starts is at 0, but this negative number here, that means it has moved right 20. So instead of this being at 0, this is actually now going to be at 20. This end point, which is normally at 360, has gone this way, 20. So that's now going to be at 380. This middle point, right in the middle, is normally 180, but it's gone that way. So it's now at 200. And so, where's our 0 point on here? Our 0 is actually going to be here, which means we'll have a bit of a graph coming back this way as well, if we were going to do it. And there, this one, if we put our 2 and our -2 on there, it's finished and it has moved to the right 20. Now, you could get ones where it combines it moving up and down and moving left to right and has a different period and has a different amplitude, but honestly that would be a horrendous question to give you, and it's unlikely you'll get one like that. But let's look at one more that is maybe similar to how you'd get one in a past paper. So I'm just going to draw a question out for you, and then we'll go through it. So here we go. We've got a question that says, below is a function with the equation y equals a sine b x plus d. What are the values of a, b, and d here? So to start with, let's deal with a first. A is a number in front, and that's always the amplitude. What is the amplitude of this function? Well, from the middle to the top, it's 4. From the middle to the bottom, it's 4. So that must mean the amplitude is 4. Our value for A is 4. Now, B. B is the period. And that's telling us how many times does it repeat the cycle in 360 degrees. Now, obviously, that's a little difficult to see here because we don't go from 0 to 360. So what we have to do is work out how long one cycle is and then say how many of those would fit in 360. So it starts here at -100 and goes up to +80. So it is 180 from start to finish. If it's 180 from the start to the end, that means you could get 2 of them in 360. So the value of B is 2. And then finally, D, that's how far left or right it has moved. Well, normally, this would start at 0, and it has moved left 100. So that must mean D is 100, and it's positive 100, because remember, if it's moved left, the number is positive. And so that's all we need to know for the moment about trig graphs. We need to be able to draw them and recognize what values they have from the question. Okay, so hopefully that was all understandable. I know it's a slightly sort of vague concept and it's a bit new to you, but if there were any problems with it, you know how to get in touch. Thanks for watching.